Okay, so with that, I'd like to introduce Hito Coleman with TDX Power. He'll be moderating this next section on remote system architectures. Hito Coleman has been active in distributed energy business for over 35 years. Green Toolbox, his consulting business, is currently engaged in development of innovative renewable energy systems incorporating the latest smart grid and microgrid concepts. So Hito has extensive hybrid system experience, as well as specific expertise in wind turbine design and deployment, solar systems, biomass projects from anaerobic methane to wood chips, and an array of system storage components. So Hito also was referred to as one of the gray beards in the room, although Hito, come on up here and let us know what you have to say.
Thanks, Kat. Thanks for being here. I appreciate the opportunity to give an overview of this session. And I sort of designed my talk as an overview rather than specifically get into any of the specific architecture or design issues as a way of giving some context to the rest of the afternoon. Spacebar, or do I have to engage the item first into the play mode? About there, right?
There we go, okay.
Let's go back. Let's get rid of that. All right. So when I talk about architectures, I start out thinking, you know, what is an architecture? We most often talk about architectures in relationship to buildings, but when we talk about architecture in relationship to electrical systems, it's a way of getting people to think about it in a slightly different way. And maybe it's emotional, but it provides some context for people to understand what's going on. And what we're doing with our system architectures really defy what I contend is the normal perceived notion of what utilities are. And so I contend we need to do a better job at creating images for what we're talking about. And I'll get into a little bit about why that is. And I think at the end of the day, if we can do a better job of explaining ourselves, we'll have a better chance of succeeding in terms of showing more people will understand what we're doing, more people will appreciate what we're doing, and more people will see the value of it. We've all seen a number of these. This is really architecture, and this is an image. There's nothing on there but image, but this is what sells, right? We need things like this that sell what we do. And if we get caught up in our language and start pushing our language on people, we will confuse them. It doesn't translate very easily when we talk about our internal technical lingo. So what is really good architecture really creates an image in somebody's mind, a lasting vision. And it allows you then to communicate, and it communicates with all these people that really matter to us. Now, most of us people that have been in this room for a long time, we came from the technical side. And we will fail if 5 years from now it's only technical people. When we're outnumbered by 5 to 1 by the policy people, by the regulatory people, by the finance people, then we will have actually done something. But we will never win as long as let me go back here. We'll never win as long as it's just technical people. And our language is very technically oriented. It's not very conducive to communication. And doing the language correctly will allow us to create vision in the part of all those constituents out there that really don't understand what we're doing. So let me start with the word penetration. 2 years ago at the Wind Diesel conference, I made a comment that when my wife saw a presentation with the word penetration, she turned to me and she said, "That's gone. You can no longer go to a talk and use that word. That is just so offensive." And having grown up with that word for 20 years in our lingo, it never even occurred to me. But it's just an example about how our language actually can offend people and confuse them and not give them the information that they need to be helpful to us. I'm having a lovely time with some thing here. So I get in and started going, high, medium, low, all right? So today alone, I think I heard 4 different definitions, different uses of the word penetration to define what a system was doing. Some people talked about what it instantaneously was doing. Some people talked about its rated capacity. Some people talked about its energy. And some people talked about penetration as a definition of the system, how a low system was different than a medium system was a high system. That's amazingly confusing. Now, I don't know who else in the room is sort of catching this, but we can say it and we think we know what it means, but when you start trying to definitize that and write it down in a simple sentence, it gets very difficult. So I'm going to sort of address that issue for a second, because if we don't get our language right, we can't communicate. So here's a couple suggestions. Renewable contribution, like how much energy does the system make? Like, let's take a year. That's a really good measure for the economists, for the policy guys to say, yeah, I put a system in, it looks like this, and it's taking 40% of the energy per year. And I would contend, of all the presentations we've seen so far, it's hard for anyone here to say, I know what that system did on a yearly basis, because the data was not presented that way. So that's the very basic thing we do. We save energy, and we don't talk about it. It's not our number one thing we talk about. We talk about all kinds of other things, all technical things. Here's another one. The renewable fraction is probably the closest thing to a renewable, to the penetration number that we used to use. But quite frankly, we are now building systems where the installed capacity of the renewables exceed the average load and exceed the peak load, right? We build systems like that. And there was a couple examples. PowerCore had an example, okay? We do it all the time. Sandpoint is like that. St. Paul is like that. So if you use the old definition of penetration, you cannot get to 200% penetration. What the hell does that mean? So you have to have a different language here. So this is a suggestion that maybe you start using renewable fraction. That's how big the renewable asset is compared to how big the average load is. Because we all know the renewable asset doesn't run at 100% of its capacity year long. It's got an ups and downs and it bounces around. But that also starts explaining to you what your configuration might have to look like. If you're starting to get above 50, 60, 70, 80% in a renewable fraction, that means you've got a big resource there, and you're going to have to balance that very differently than if you had a small resource. And it's a lot more informative. And I'll also contend the low, medium, and high, the boundaries between low, medium, and high are as fuzzy as you'd ever want to expect them to be. I mean, they're just undefinably fuzzy. So now I want to get to the next one. I mean, that was sort of the soapbox on some language. And I suggest you think about it a little bit, and I think it will start to ring true that we need to communicate in simple, clear, concise terms, and in terms that matter to people. And basically, it comes down to money. That's the value proposition here. So smart grid, it's clearly got the biggest buzz in the space that we're sort of related to. It's a huge umbrella. You can get 100 smart grid definitions by just going online. Everybody's got their own little tweaks of what that might mean. So basically what they've created is a vision, a big umbrella that they can just lump all the utility promises, all the great things the utility is going to do for you in the next 100 years is lumped under that umbrella. And that's great buzz, and it really gives them the power to start changing the way things are done and to move money around. And that's what's really happening is under the smart grid banner, there's a lot of money moving. And I'm going to get to what it's moving for in a second, but oh, this is great. That whole image is gone. Smart grid. That was a smart grid image. So here's this. This essentially is what I contend the key issues are when you talk about what smart grid really does. Basically, they're talking about much more complicated generation dispatch decisions. The utilities today, and I don't want to offend anybody who's in the utility industry, but essentially they're pretty archaic in terms of making decisions. They're used to extremely long ramp times, and extremely long ways of making decisions. And for them, the complex generation dispatch decision is all economic. Which plant do I run now versus later? But when we start talking about it, we get a little more sophisticated than just the economics. Everybody is now talking about getting more renewables, okay? That's exactly what we're all about. Dispatchable load control. That's what they say they want to do. They want to be able to basically moderate loads in your air conditioner or wherever it is to sort of balance things out so that the smart grid can run better, so that it can be smarter. And they talk about storage, including electric vehicles, as the new smart grids. They will have some of that because that's going to make the utility run better. And then, of course, advanced metering, data processing. They're just waking up to the fact that it might be nice to know what's happening on their lines, because quite frankly, they have a limited knowledge base because they started at a generation asset, not at a load asset. They always thought that they only needed to control generation and they would follow load, and now they're understanding they need to get on the load side to do a better job. So they brought that under the smart grid umbrella. The last two items are actually clearly the most important in terms of changing the scenario, and that is, what's the regulatory environment doing, and how does the regulatory environment look at a smart grid? And that is really a challenge right now in the smart grid industry because nobody knows how to pay for smart grid upgrades. And the utilities are breaking out of the traditional utility structure and the way they got paid. As soon as they start getting into your house and turning off your air conditioner or managing loads or managing distributed generation, they've entered a new business model. They need the regulator to adjust the vision of the regulation. And so there's a regulation environment going on that will not allow smart grids to happen until it's done. And that's exactly what we have to do here in rural Alaska to get the utilities expanding their vision to allow the kind of things we need to do with selling heat and with modulating load and all the other things that are going to allow us to increase the amount of renewables that we put on these grids. You see, I did that whole thing without saying penetration. It took me a year to figure out how to train myself to stop using the word. And then the last thing is new financial mechanisms. None of this stuff is cheap. It requires capital costs. You got to have a payback mechanism. So you have to structure somebody that's going to pay back for this new service. And that's breaking out of the traditional regulatory bounds that are put on utilities. And I can go into this in chapter and verse in Alaska, but basically we're breaking out of the traditional bounds. So I contend everything we're doing in remote Alaska and everything we talked about in this wind diesel session, basically it's a smart grid on steroids. We're way beyond what most utilities think smart grids are, because they know they can't get there fast enough. And the fact is, we can get where they can't get. We can get to very high levels of renewables. We can get to very sophisticated load dispatch control. We can get to very advanced dispatch decisions where they will never get there because the risks that they incur and the costs that they're going to have to put into these systems is so enormous that they're going to struggle to learn anything. Where in little rural villages, we can learn that just as well, very quickly, very inexpensively. And I would contend that if we would start adapting their image and co-opting their vision, that they would start realizing us that we're a huge asset to their vision, and they will start paying attention to what we're doing and learn from us, in which case everybody here would have a chance to have their dreams fulfilled a little bit more. And whether that's the rural community who would see some resources pulling in, or some of us technical people who would just like to see us do more interesting projects. So again, I'm going to come back to this. If we can't talk the talk, we can't walk the walk, and it's in the policy, regulatory, and financial arena. There's a number of people who've given plenty of examples of we can talk the walk and walk the talk technically. We can save fuel. We can do all that stuff now, but we haven't crossed over to this other barrier, the policy, regulatory, and financial side. And until we do that, we'll never really get anywhere. We've got to have these people embrace what we talk about. So let's talk about, this is the last little wrap up on this soapbox, and I'm sorry to put you through this, but I think it's important. Boulder's the smart grid city, right? I don't know if people have been tracking this. This is, there's a number of smart grid going on in the US and in Europe, and Boulder is considered the smart grid city. This was the big hoopla. $100 million was going to be put into Boulder to be smart grid. And everybody got behind this, had big image. This was started in 2008. And you guys from Colorado know this story. And I'm not going to give you all this stuff. But they had 4 major initiatives to turn Boulder into the smart grid city of the future, right? So here they are. Transform the existing metering infrastructure to robust dynamic electric system communication network providing real-time, you want blah, 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 blah. That's all marketing hype. What did they do? They just put in a fiber optic net over a small part of the city, right? Enormously expensive, very valuable, does everything that gobbledygook does, but that's all it was. So they got smart grid to put in a fiber optic network. That was interesting. Then they said, okay, we're gonna convert substations to smart substations. So for the first time in their life, they actually put a meter at the substation. Now that's a really big deal. So now they actually know what's going out of the substation. Before, they had a guy go out there and rummage around and try to find a meter, you know. So they did that. We're talking $100 million here. Okay, then they did, at the customer's invitation, they would install they say in-home control device to control your system. Well, they actually didn't do that. They put in 24,000 smart meters. They didn't no control yet. They said, well, first we'll start you with a meter, because if you had a meter, that would be really good for you, because then you'd know what you're using. And you can buy these meters in like 100 different places now, but they started putting meters in, so now they're looking at the meters. Actually, to do the control side, they're gonna demand that you have to have a centralized AC system, because the AC was all they were gonna control. So you have to have a central AC system in your house, and then they will talk to you about putting in an actual load control device, which they haven't done yet. And there are 44 million over budget. And then the last thing they're doing is this was the great one, the catch-all. We're gonna do everything to make DG and wind and solar really work, okay? So as of today, 3 years later, they haven't done anything. They have great hype. They have talked about electric cars, V2G, all that stuff. So you take Boulder, okay, the Boulder probably has a load of 25 megawatts. Let's drop 5 cars in there, V2G cars, and see what the impact of that is, and see if we can measure that. So they have a huge problem coming up with that. All right, so that's what smart grid is actually doing. When you get through the hype, that's what they're doing. Okay, so let's just take Sandpoint, Alaska. So we're just installed 2 V39s for 1 megawatt. We got a 700 kW average load. We put in a bunch of dispatchable heat load. That's all radio controlled. We automated the diesels. We got a web-based data acquisition and control system. Okay, not so bad. Sandpoint City is a smart grid city. We got a 40% renewable contribution, plus saving a bunch of heating fuel. We have a renewable fraction of 140%. Now you got to remember, it wasn't that long ago that 20% renewable fraction scared the pants off of most utility guys. Right? It wasn't that long ago. There's still utilities out there today that'll tell you 20% scares them. Okay, we got dispatchable loads, automatic generation, SCADA based, all this stuff. All right. So everything on the big promises of smart grid, the smart grid that we didn't do, the only thing we didn't do, we touched every button on this list except energy storage. So we didn't do energy storage. It's expensive, it's a great idea, there's some real promise there, but we didn't do it. So I would contend that our little Sandpoint is a better smart grid city than Boulder. And if we would start using that lingo and start using that hype and explaining that to people, I think people would start giving us a little more respect and put us into context for what we're really doing. So the real question is, of all the projects we got here, which one is the next smart grid? And why don't we start taking that branding? So thanks very much.